Salam sejahtera dan selamat petang. Terima kasih kepada anda semua yang sudi berlintas langsung dengan Tim Edidik, Jabatan Pelajaran WPKL, dan Majlis Guru Cemerlang WPKL. Dalam kelas online sepanjang arahan PKP oleh pihak kerajaan. Semoga anda semua sihat selalu dan sentiasa berada di rumah di samping keluarga yang tersayang. Ayo kita teruskan sesi kita pada petang ini bersama Cikgu Li, Guru Cemerlang Kimia dengan tajuk Jadual Berkala Unsur. Harap anda semua gembira dan ceria dapat belajar dengan guru-guru yang terbaik kami sediakan. Persilakan Cikgu Li. Ya, Cikgu Li.
Okay, can you see me?
Yeah.
See my screen? Hello, Jenny.
Yeah. The screen not yet.
I share with you. Can you see the PowerPoint like just now?
Not yet.
Oh. So can you see the screen ready now?
Not yet.
So can you see the screen ready now?
Okay. Screen's dah dah. Not yet.
I share with you.
Okay. Already can. Screen's dah dah. Not yet.
This one, eh?
Okay. Already can. Screen's dah dah. Not yet.
This one, eh?
Okay. Already can. Screen's dah dah. Not yet.
Hello. Can you see my screen?
Yes.
Jenny?
Yes, I can see your screen.
Okay, so I will start lah ya. Okay, terima kasih kepada Cikgu Jenny yang sudi menjadi moderator pada petang ini. So, kita jumpa semula anak-anak kali kedua kita cikgu ada di kelas. Okay, disebabkan ada ramai yang minta ya. Ada ramai yang memohon untuk mengadakan kelas tentang periodic table. Jadi cikgu ambil kesempatan inilah untuk mengadakan kelas ini. Okay. Jadi saya harap semua dah bersedia. Jadi terlebih dahulu. Hello. Terlebih dahulu saya ingin menjelaskan bahawa kelas ini bukan cikgu nak ajar semula ya apa itu what is the mean by periodic table. So for this lesson is like speed up, to read up, or you can say to revision about what is the secret of the periodic table. Okay, so this is our outline today. So we are going to discuss about the secret of periodic table of elements, and then physical properties of alkaline metals, halogens, and noble gases, and then some chemical properties for alkaline metal, halogen, and also the noble gases. This one I will cancel. Okay, and then a little bit about transition element, periodicity, and ending part is about the questions and Q&A. This Q&A is teacher will share the worksheets. I hope you get the worksheet ready. Then later we will talk about that worksheet. Okay, so here I would like to start our class now. Are you ready? Okay, so I will start here. If you see my slide here, you can see there's a periodic table. Okay, all well known. All the elements are placed in the periodic table according to the their chemical properties, their electron arrangement, and so on. So as you see, the elements is actually placed in the periodic table, followed by their proton number. You can see hydrogen is 1, and then helium is 2, lithium is 3, and so on, right? So they are placing in the periodic table according to the proton number. And then there are few things that you must able to know is, for example, okay, teacher take one example. Let's say we have lithium. Lithium, the proton number is 3, right? So proton number is 3. So when you write the electron arrangement, sorry. Okay. Lithium, yeah, lithium 3. When you write the electron arrangement, it is 2.3, 2.1, sorry, 2.1. And then, for example, we have chlorine. Chlorine, 17. So when you write the electron arrangement, it should be 2.8.7. So how I can know that? Okay, sorry, 3 lithium, and then the chlorine, 17. So here you got 2.1, and here you got 2.8.7. Okay, so for the lithium is 2.1. So how that I know that it placed in the periodic table? So when you see this number, the last number is the number of valence electron. So the number of valence electron is tell us the group. So if you can see here, lithium is placed in group 1. The chlorine is 7. So the chlorine is over here. But why the number is 17? Because here, the transition element, we got 10. So it's actually 10 plus 7. Okay, 10 plus 7. That's why you get the group of chlorine is 17. Okay, maybe other country, they still use 7. But for Malaysia, our syllabus, we use 17. Okay, so over here, you can see we have group 1. Group is the one that, like this. Okay, this is called group. So we have group 1 until the last one is group 18, right? Okay, done about group. Secondly, you want to know about the period. So how do I know about the period is, we look at here. So for lithium, it has 2 shell occupied with electron. Okay, 2 shell, 2 shell occupied with electron. Whereas for chlorine, it needs 3 shells to occupy the electrons. Okay, so 2 shell means what? So if you check the position of lithium, it placed at period number 2. So this is the secret. Okay, I repeat. Lithium use 2 shell to occupy the electron. That's why the position of lithium is at period number 2. Whereas for chlorine, chlorine is 287. 287, meaning that chlorine will use 3 shell to occupy the electron. So you check the chlorine is here, right? Chlorine is here, and it is placed at the period number 3. Okay, that's how you determine the period and the group. Okay, beside that, you also need to know that the position. As you see here, the color, as you see here, the color. Okay, you can see the color. The yellow one is revealing the metal. So the metal, alpine metal. This is the one that we are going to focus. Okay, and then this corner. Okay, this corner, you have wait. Over here, I would like to draw the semi-metal first. So over here, sorry. Okay, all these are called semi-metal. So this side is the non-metal. So over here, this side is the metal. So this is some of the things that you must know in the Jenny, can you hear? Is my voice okay?
Okay, you can continue.
Okay, so this is, and then over here, okay, over here, you know that this is the transition element. Okay, transition element, but not only here, you have two part is bring down here. This is also considered as a transition element. We have lanthanous and also acetylase. So these are called transition element. Okay, next. Okay, so the second part is I will talk about the atomic radius. Okay, please give me a few seconds because I need to check about someone join the class by using the Google Meet. Okay. The student joining the Google Meet, please go to live. I will close this Google Meet now. Okay, I will close very shortly, Please go to the live. Okay, the one join the Google Meet, sorry, please go to the live, okay. Okay, so I come back here. First thing I will talk about atomic radius, which is very, very important. Okay, I will talk about the trend of atomic radius. Yeah. Okay, the trend of the atomic radius. So here I show you how the scientists measure the atomic radius, because the substances we have different things. We have some are metal, some are atom, some are covalent, some are ionic. Okay, so sorry for the disturbing here. Okay, firstly, I will discuss the changes of atomic radius down the group. Okay, down the group, as you can see here, down the group is the atomic size is in increasing order. Okay, why? Why the atomic size is in increasing order? Okay, firstly, I will focus on the group 1, 17, and also the 18. So for the group 1, 17, and 18, Jenny, the sound is like I have double voice.
Yeah, Cikgu Lee, you close your Meet already?
I haven't.
You just close your Meet because maybe they got the the sound there.
You join the Meet or not? You please join the Meet and tell the student.
Okay, then you
close, then you cannot join.
You use 2 devices or 1 device only?
One.
Okay.
So yeah, okay.
Laptop, speaker laptop.
Yeah, okay. I close again.
Speaker laptop pun tutup.
Speaker laptop tutup.
Volume dia down kan?
Okay, sorry for disturbance. Okay. So the atomic, I repeat again, atomic radius down the group. Now we focus, number one is about down the group. As you can see, the diagram here show you when down the group, all the atomic radius is in increasing order. For group 1, 17 as well as 18. So teacher just put them together lah. So we no need to discuss 3 times. So again, group 1, 17 and 18. Down the group, the atomic radius is in increasing order. Okay, so you would like to know why this happened. Okay, to know this is here, right? We have, for group 1, you can see the number of shell occupied with electron is increased. So here we started with 2 shell, 3 shell, 4 shell, and so on, as well as group 17 and also the 18. Okay, so this helps us to explain why the size is in increasing order. Okay, so number 1, if we say number shell increase. So for this one, when you say number shell is not good, right? So how do I mention that? So we say what? Number shell occupied with electron. You need to put that. Because many students will just say number shell. So you say number shell occupied with electron is in increasing order. So beside that, valence electron further from the nucleus, right? It's very clear. So because of this, right? Because of this, force attraction from the nucleus towards electron become weaker. So very, very important, you must mention force attraction from nucleus. Because many students will say force attraction between particles. That is wrong. Okay, again, you must mention force attraction from the nucleus. Okay, next, we'll talk about what happened when across a period. When across the period, the size becomes smaller. Just now, down the group size become bigger, right? But now when across the period, the size becomes smaller. Okay, why this happened? Okay, so you can see here, this is a statistic show you. Okay, it's in decreasing order. Okay, so why this happened? Again, we need to study the electron arrangement. When you see the electron arrangement, you can see the number of shell occupied with the electron. Okay, number 1. Number 2, as we compare, number 2, as we compare the sodium, when we compare the sodium, sodium have 11 proton, which means in the nucleus you have 11 positive charge. But for the chlorine, if you have 17 proton, means that you have 17 charge. So this condition, this situation shows us that the chlorine, the nucleus force attraction from nucleus for the chlorine becomes stronger compared to sodium. So obviously here you can see all of them using 3 shells, right? 3 shell, but the difference is the force attraction from the nucleus. Okay, so how to explain in theory? Then it's like this. Okay, so you have this. So first we say the number of proton in the nucleus increase, right? Increase. So when the number of proton increase, it will affect the positive charge of the nucleus. Okay, beside of that, then the nucleus attraction force towards the electron, or you may say the valence electron, becomes stronger. Okay, becomes stronger. So the electrons are pulled closer to the nucleus. That's why the atomic radius becomes smaller. Okay, so this page telling you about the atomic radius. Okay, I discussed about atomic radius. Okay, next. Secondly, we'll discuss about the trend of melting point and boiling point. Okay, for this part, teacher will focus on group 1 and group 1, group 17, and also group 18. Okay, so as you look at, please focus at group 1 first. For group 1, you can see here, okay, very clear that when down the group, the boiling point is in decreasing order. Okay, so why this happened? Why this happened? Okay, let's look at the electron arrangement and the number of shell occupied with electron also. Okay, so we can say that the atomic size increase. Atomic size increase, yeah? Okay, I'm missing. Atomic size increase. So attraction between the nucleus and valence electron decrease. Okay, so here decrease, yeah? Metallic bond decrease. So because of the metallic bond decrease, that's why it requires less heat energy to overcome this force. That's why the melting point and boiling point is in decreasing order for group 1. That's called alkaline metal. Okay. So remember, so when going down to group 1, okay, down the group 1, melting point, boiling point is in decreasing order. Okay, now let's move to group 17. So for group 17, also the same, you can see the number of shell occupied with electron is actually increased. But what is the difference between the group 1 and group 17 and also group 18? The difference is the group 1 is metal, so they have metallic bond. But for group 17, they form covalent bond. They form covalent bond. So the force between their particle is van der Waals. Van der Waals is quite weak force. Okay, for group 18, the noble gases, group 18, they are monoatomic, so they have also the force between the particle, that's van der Waals, they are very weak. Okay, very weak. Okay, so we can say the size of molecule. Okay, size of molecule. The size of molecule become bigger. So the force, the van der Waals force is weak. But when the size of the molecule or the atom become bigger, then the force becomes stronger. This is always students make a mistake. I repeat, the van der Waals force is not strong. But when the size of molecule or the atom increase, then make the force become stronger. So that's why when down the group 17 or group 18, the force becomes stronger. So when the force becomes stronger, okay, here, you have to remember the melting point and boiling point is very close about the force and the heat energy. When the force is strong, so it requires more heat energy. So now we say that the van der Waals force is strong. So it will require more heat energy to overcome this strong force. That's why when down the group 17 or down the group 18, the melting point and boiling point is in increasing order. Okay, so this is, you need to mention about melting point and boiling point in group 1 and also group 17. Okay, in group 1 and also the group 17. Okay, I remind you, show you back. Okay, this is the things that you need to be very careful, because a lot of students always do the careless mistake about how to explain the change or the trend of melting point and boiling point when down the group. Okay, so next I'm going to discuss about how does electron structure affect reactivity. Okay, first I'm going to focus on the group 18. When you see the group 18, happily, the electron arrangement, they have duplet. Okay, they have, here is duplet. This one is duplet. Right? Here is octet. The rest all are octet. So what happened when they have this kind of electron arrangement? Right? So we say they have achieved the stable electron arrangement. So that's why they are chemically inert. Okay, they are chemically inert. Okay, how to explain? By theoretical, how you explain to people why the group 18, the noble gases are chemically inert? So you can start to explain by telling people they have or they has 2 or they have 8 valence electron. Then this is called the duplet or octet electron arrangement, right? So because of this, we can say like if normal language, the outermost shell fill full with electron. That's why doesn't need any more electron. So they don't need to gain, lose, or maybe share electron with other atoms of element. That's why they are chemically inert. So beside that, we also can use this point to explain to people why they are monoatomic. Why they are monoatomic? Because of these 3 points. Okay. Okay. So next, still in how the electron structure affect the reactivity, but now I'm going to focus on group 17. Okay, so for group 17, as maybe you already study, have discussed with your teacher or maybe your friend, for group 17, when down the group 17, the reactivity is in decreasing order. Okay, it's in decreasing order. Okay, why? Why this happen? Okay, to see this, why this happen, I'm going to share you one video. Okay, to prove that it's in decreasing order. Okay, this is actually the combustion of fluorine with the iron. Okay, iron wool, you can see. Okay, iron wool, this chlorine. Okay, you can see here they collected the gas. Then now let's say we see the bromine. What happened to bromine? Okay, bromine with iron wool. Okay, from this video you can compare the reactivity. It is in decreasing order, meaning that the fluorine is the most vigorous compared to chlorine, bromine, and so on. Okay. Okay, the iodine is purple in color, very nice color. You can see that. Okay, you see iodine, very slow. Okay. So why this happened is because, for example, teacher take the, okay, let's say we have chlorine, right? We have chlorine 287, chlorine 287, the bromine 2, 8, 18, and 7. So they also will try to achieve the stable octet electron arrangement like the noble gases, like the group 18 just now. So how they achieve? They must gain 1 electron. Okay, they need to gain electron. But because of the size, okay, we can see here the size, yeah? Okay, the size become bigger. So the force attraction become weaker. So if we have fluorine until iodine, of course, the fluorine will be the first get the electron, then followed by chlorine and so on, right? Okay, so here I would like to share with you how to explain. Many students, they know, but when come to chemistry language, you are weak on that. Okay, here our teacher would like to share with you. Firstly, you may talk about the atomic size. Okay, may talk about the atomic size, or maybe you talk about the number of shell. Okay, so I would say my first point, I will talk about the atomic cells increase when down the group. So the outermost occupied shell of each halogen atom become further away. Okay, further away from the nucleus. Then this will affect the force attraction from nucleus towards the electron, become weaker. So more difficult to attract one electron to achieve the SOEA. That's why when down the group 17, the reactivity is in decreasing order. Okay, it's in decreasing order. Okay, next I will show you about the group 1. Okay, group 1. Okay, very quick, see the reactivity. So this is the lithium react with water. Okay, lithium react with water, and this is sodium. You can see sodium very light. It can float. Yeah, the density is lower than water. It can float on the surface water and it can dancing. Okay, so yeah, this is the equation shows how the sodium react with water. It forms sodium hydroxide and hydrogen gas. Okay, next one is we take the same size, yeah, the same size, the manipulated variable, the same size, the constant variable, sorry. So you can see this is the potassium. Okay, it's more vigorous compared to the sodium. Okay, francium. And this one, francium. Lastly, you are going to see is the cesium. Okay. Now, yeah. Please don't do this, yeah. When you, okay, you must have the with teacher. Teacher will do the demonstration to you. Okay, for here I show you is to let you know the comparison between the down the group for group 1. Okay, we want to know the activity. So down the group 1, as you see the video, you know that is in increasing order. Okay, so now how to use the chemistry language to explain this? Okay, before that, let's look at the sodium. Sodium, as you know, sodium is 2.8.1. Okay, so sodium 2.8.1 is not octet, so you need to get away the electron. So it will form the sodium ion, right? So to compare the reactivity is to compare how easy they can donate this electron. This one must be donated. Okay, so here I will show you how to do it. Firstly, you can talk about the atomic size increase, and then you talk about the single valence electron is further. You can see up there, okay, it's further from the nucleus. That's why the force attraction, again, I mentioned force attraction from the nucleus, not between particle, okay, it's nucleus. Okay, that's why easier for the atom to lose the electron. Then they easily to achieve the stable octet electron arrangement. Okay, this is how you explain why when down the group 1, the reactivity is in decreasing, in increasing order. Okay. So just now we have discussed about in general, right? The atomic size, the trend of atomic size. the melting point, boiling point, and then the reactivity. So now it's time to go into the group 1 elements. Okay, this one also very quick review about what is about the group 1 elements. So for group 1 element, the special name is called alkaline metal. It's called alkaline metal. Okay, so as you see here, just now I already mentioned about the melting point, and here I would like to show you how we store the alkaline metal. Okay, if you look at the diagram, alkaline metal is you need to store them in the paraffin oil because they are very, very reactive. Okay, let's see what is the reactivity. Before that, I will show you one video about the physical properties. You can see here we can cut the alkaline metal easily by using a knife. Okay, you can see that after you cut, it becomes very shiny. So it shows that they are actually gray color. Okay, their physical appearance is gray in color. Okay, so here is the first chemical activity I would like to show you here. Number 1 is they can react with, okay, number 1, they can react with water. So when just now I show you the video, this is the equation. When they react with water, it will form hydroxide and also produce hydrogen gas. Okay, you can notice that lithium, sodium, potassium, they all have similar chemical properties, meaning that they produce hydroxide and also the hydrogen. The only difference is the reactivity. Okay, they differ in reactivity. Okay, this is the first chemical properties. Number 2. Number 2 is about react with oxygen. Okay, react with oxygen. This is the setup, how you want to conduct the experiment, burning alkaline metal with oxygen, use the gas jar, and need to do in the future chamber, right? Because alkaline metal is very, very reactive. Okay, so next we want to see another chemical properties is they also can react. Sorry, this is supposed to be chlorine, right? Chlorine. Okay, they can react with chlorine as well as the oxygen. So for group 1, these are the 3 chemical properties that you need to taking care. So repeat, water, oxygen, and also the chlorine. Okay, so why we study group 1? Are they having any uses to our daily life activity? Yes, of course it has. So here I'm going to show you these are the uses of the alkaline metal in our daily life. You can use, like for example, sodium chloride, we can use at the salts, and then lithium can make the battery in your calculator, your calculator, and potassium is rich, a lot of food that contain potassium. So here also some other things that we can use from the group 1 elements. Okay, this is chlorine. Chlorine. Okay, so next I will move on to another slide. Okay, next part is about group 17. Okay, group 17, as we know, they are called halogens. Halogen. Okay, first part here is I just repeat from the previous slide, just recap back about the atomic size and also the melting point and boiling point. Okay. Okay, so this video I'm going to show you. Many students, when teacher asks, what is the color of chlorine, bromine? Some of them know, some of them maybe it's brown or maybe it's yellow. They are not sure. So here, I will take this opportunity to show you the video about the appearance about the chlorine, fluorine, and bromine. You can watch this video. Okay. The first one is, okay, very fast. Okay, so the first gas jar is fluorine. Second one is chlorine, bromine, and iodine. So from here, you can see very clear their color. So the fluorine is almost colorless. The chlorine depends on the concentration. Okay, it's very light, means they will have light yellow, a little bit of green, right? Okay. Okay. So this part I will move. Okay, second part is about the group 17 also, but here I'm going to talk about the chemical properties. Okay, first is chlorine, the halogen can react with water. So these are the setup when you want to conduct the experiment. Maybe you will ask, teacher, why the setup is different? If you look at the first diagram, we need the Livieri tube. For B, we just use the dropper, but the C one, we didn't use the dropper. You can see the iodine crystal here. Why we need to use the different setup? This is because what? Their physical state is different. Okay, chlorine is gas, bromine, it can be water, liquid, yeah, and then this is solid. Okay, so this is the equation. When you see when we have chlorine in the water, it will form HCl and HOCl, as well as the bromine and the iodine. You can see they have similar chemical properties, but in different reactivity. Okay, next one is about, they also can react with sodium hydroxide. Okay, so when they react with sodium hydroxide, they will form two salts. You can see here the NaCl and also the NOCl. Okay, let's watch the video here. Okay, if you look at here, it shows what? HCl is an acid. So if you study in your lower form science, acid react with alkali will form salts and water. Salts and water. So when we put the chlorine in the sodium hydroxide, if you notice here, it will form yeah. Okay, you notice that here it will form two salts. You form two salts, right? Okay, why this happen? Okay, why this happen? I'm going to show you here, because here, you see when the chlorine in the water, although here we use sodium hydroxide, meaning that the sodium hydroxide solution is also actually contain the water. So the sodium hydroxide will react with the HCl to form NaCl. And it also will react with HOCl to form the NOCl. This is the one that we take and use in our daily life as the chloro. Yeah, okay. Next, I will show you another chemical activity. As just now, remember I showed you when we burn the iodine, the chlorine, fluorine in with the iron wool. So this is the setup. Okay, so you can see here, this is the burning. When you burn chlorine or bromine in the strongly heated iron wool, it will have, you can see this observation. Okay, and this will be the equation. So here, I remind you, the product is FeCl3, meaning this is Fe3 positive, not Fe2 positive. Yeah? Okay, please don't make a careless mistake. Okay, and you can see the color. This is just now that one is FeCl. Okay, so recap. For these are the chemical equation, general chemical equation for group 17. You no need to memorize all the equation. I can just take X represent the halogen. So when halogen with water, it will form H(X) and HOCl. With the sodium hydroxide, remember it will form salts and water. But for this case, it will form 2 salts. If you use HCl, it's only 1 salt. And when it react with iron, it will form iron 3 halides. Okay, iron 3 halides, and make sure that you balance the equation. Okay, safety precaution. So as we know that halogen here is very poisonous also, as well. For example, the bromine, bromine, you cannot in contact with bromine a lot indirectly. So that's why when you conduct experiment, we need to do in the view chamber and also wear our lovely goggles. Okay, next. Okay, next I move on. Next is about the transition element. So transition element, I will focus on their special only, their special properties only. Okay, others thing you can study on your own. So for here you can see the atomic radius here for the transition element is almost the same. Okay, almost the same, but the electronegativity is a bit different. Okay, different because across the transition element, they have a little bit different from the others. Yeah. Okay. Next. Okay. So these are the 4 special properties that I want to focus. What is mean by special? What's mean by special? Special means something I have, you don't have, right? Okay. For example, like you say, can I say conduct electricity? Or maybe I say high melting point is a special properties for transition element? No, because other metal also have these properties. So can conduct electricity, has high melting point, is just common properties for all the metals. When you are talking about transition element, you are talking about special properties, you need to mention about these 4. Okay. So what are these 4? They form colored compound, different oxidation number, they form complex ion, and they can act as catalyst. Okay, form colored compound. These are all my lovely chemicals. Okay, you try to get note of them, try to love them so that you can remember their color. Okay, next one. What is mean by different oxidation number? For example, iron. Okay, just now we have iron 3 chloride because the Fe3 positive. So we also have iron 2. When you say iron 2, the oxidation number is +2, positive 2. Iron 3, the oxidation number is positive 3, as well as others. Okay, you can see here. So for example, like manganese, very famous. You can see here, I show you 3. It's actually not only these 3, we got more than this, right? Okay, you can check later. Form complex ion. When you say complex, the name when you see the complex means something like, wow, very difficult, very complicated, right? Yes, it's true. So here in the third diagram, you can see these are the example. Okay, these are the example. These are the example of the complex ion. Okay, when you see here, you can see here the NH3. What is the NH3? NH3 is actually amine. How many amine? They got 6, right? Got 6. That's why the name is hex. And then why here is 3? This 3 is because the cobalt, this cobalt is actually CO3 positive. right? Okay, so lastly is about the catalyst. They can act as catalyst. So catalyst, you are going to study in the last chapter, Form 4, in the first Form 4, Chemical in Industry, the last chapter. But here I show you, this is not really that you don't know. The first one is we can use nickel to make margarine, right? We can put in our roti and to make a cake or whatever, okay? So this is a little bit about transition element. Okay, next I will move on to the periodic table, elements in a period, but I will focus on the period 3 only. Okay, the period 3, these are the period 3. Okay, period 3, we focus on sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. So as you can see here, they are actually using 3 shells to occupy the electron. Okay, so these are the things that you might need to know about the period 3. But don't worry about this number. For example, atomic radius 0.156. This one you need to memorize them. What you need to know is you need to know the trend like I mentioned just now, right? Okay, you need to know about the trend, right? You just know the trend. Okay, before I move on, that's very important in the period 3 is you must know about the oxide. So as you look at here, we have sodium and magnesium, right? Sodium and magnesium, they form the oxide. The oxide is base. But for the silicon, argon, and so on, they form the oxide, but the oxide is not argon, sorry. Okay, until chlorine only, they form acidic. The special one is the aluminium form amphoteric. What is meant by amphoteric? It's like simpulan bahasa talam dua muka. So for aluminum oxide, it has basic properties and it also have acidic properties. That's why we call aluminum oxide is amphoteric oxide. Okay, so far you have any questions? Before I move on to the worksheet. Okay, so I move on to the question. Okay, so do you have this with you? Okay, I give you a few seconds to get ready your worksheet. Okay, I give you a few seconds to get ready your worksheet. Okay, I give you a few seconds to get ready your worksheet. Okay, so now I shall start our first questions. If you look at here, the diagram 1, they give you three elements with letter, not the actual name. Okay, so they give you what? They give you the proton number, right? So you know this is, you must know the proton number. These are the proton number. These are called proton number. Okay, the proton number. And you are asked to what is mean by group in the periodic table. Group. So the keyword is group. What is mean you need to explain. Okay, you need to explain. How we explain? It should be the vertical. Okay, the group is the vertical column in the periodic table is called the group. Okay, so what is the group of 3 elements? Okay, 3 elements like just now. Here, I show you the tips, right? Okay, so when see the tips, you can know that P has 1 valence electron, Q also have 1 because the PRQ are in the same group. So meaning that we say that they are in group group 1, right? Okay. So now, let's move to the next questions. Okay, let's say you're given suggested value. They ask you to suggest the value of this X. How we suggest X? If you can memorize the number, you know it. Okay? But if I don't have the number, how do I memorize it? How do I know it? So here I would like to share you a tips. Actually, the nucleon number, the proton number times 2 is almost equals to the nucleon number. That's the tips. Okay? So the question asks you to predict. So I would say 19 is the correct answer. But as you know, nucleon number, as I say, is actually 2 times proton number. If you put for 20 also be accept. Okay, because they say suggest the value only, right? Okay. So next question, write the electron arrangement for the P. This one should be no problem for you. It's quite easy. You can get it. It's 2.1. Okay. Now the Q. Q is the questions that ask about the chemical reactivity, chemical equation, chemical reaction. So they say Q reacts with water. Okay, Q reacts with water. As we know, Q and P are the same group, right? This one means they are in the group 1. Group 1, the alkaline metal. The alkaline metal, right? So by using the actual name, you see here, they say actual name. Okay, the actual name, you state the product. Remember just now we say X with the H2O, it form X. Right? So the product you can see here. Okay, by using the actual name. So I will say sodium hydroxide and also the hydrogen gas. And then lastly, you are asked to write the equation. How to write the equation? So if here now we have X, right? This X, you change to the sodium. And always remember the equation must be balanced. Okay, the equation must be balanced. Okay, many students, you may forgot about this. Okay, these 2 you forgot. The 2 so that the equation is balanced. Okay, so until here you should get many marks already. 2, 3, 4, 5, 7 marks already. This is structural questions. Okay, next. Okay, this question is combine the periodic table and also the more concept, the calculation, the stoichiometry. Remember the previous lesson we discussed about the problem solving, numerical problem solving. This is the one. Okay. So they say what? 2 mole of Q react with water. Calculate the volume of gas. Okay. So remember my tips, I say to solve this problem, you use the emitters. You can use the emitters. Okay. The first thing is you need to write the equation. First you write the equation. Okay. Then here they say 2 mole of Q. 2 mole of Q. You need to compare. You need to compare from here. Okay, from the balance equation. So this is what I say, E misses. The M is given, you no need to count. This is the R. Later you need to do the S. Again, I say E misses. Equation, more, ratio, and solve problem. Okay, so from this equation, they tell us 2 mole of Q produced. From the equation, we know there is 2 mole sodium react completely with water to form 1 mole of hydrogen. But in the question also say 2 mole of Q. So meaning that 1 mole of hydrogen is produced, right? Okay, we know the number of mole for hydrogen. Now our problem is to calculate what is the volume. So to calculate the volume, remember you need to use this formula. Volume is equals to the mole times the molar volume. So you substitute the molar volume, you get this. And please remember, write the unit. Okay, no unit, minus marks. Yeah, okay. So again, this is, you can use the tips that teachers share before E misses. Okay, that is question number 1. So now, shall we move on to one more questions? Okay, I want to move on in another question, number 2. Okay, you notice another different. Just now, question number 1 is giving you the atomic symbols without the actual name. This question number 2, I give you letter of the elements with the periodic table. This one much easier. Okay, quickly we see the question A1. Which element is noble gases? Okay, after the discussion, you should know lah what is noble gases. It should be the one from the group 18. So the answer is M. Okay, record your marks. Now you get 1 marks already. Okay, now we move on. Which element exits as diatomic molecule? You may say, oh teacher, my answer is oxygen. Can you accept by oxygen? I will say no, because you need to answer according to the letter that I use. I use only, right? I didn't mention oxygen here, so I cannot accept oxygen, right? Okay, so the diatomic molecule usually is from the group 17, right? In this case, it's B lah. Yeah, okay, it's B. Although we know that hydrogen, chlorine, oxygen also can form diatomic molecule, but the answer is rejected. Okay, because they are not listed in these questions. Answer based on these questions. Okay, next. Which element form amphoteric oxide? Remember amphoteric, I say talam 2 muka, right? Talam 2 muka should be what? The talam 2 muka should be the aluminium oxide. Okay, so what is your answer? Okay, if my answer I put here, maybe you say, teacher, can I give this? Or teacher, can I write here aluminium oxide? Correct or not? Okay, this question I would say wrong. Ayo, why wrong? Please read the question carefully. The question say, which element? Which element? Okay, which element? If you give me, for example, you give me V2O, is V2O3 is also wrong, because the question asks element. So the correct answer should be given, you must give in the element only. Okay, you must give in the element only. Okay, we move on to the B. Okay, the B, B You're given element QRW, and you are asked, why are these elements placed in the same group? Same group. Okay, same group. Remember the beginning teacher said how you determine the group? The group is you determine from the number of valence electron. Okay, so the reason is because they have same number of valence electron. Okay, and then the number 2 is you need to arrange them according to the ascending order based on the reactivity towards oxygen. So don't care about towards oxygen, towards the chlorine, or towards the water. The reactivity is the same. Now they want ascending. What's the difference between ascending and descending? So some students, they might have confused. Okay, menurun ataupun meningkat. So I share with you one way to memorize, to know it. You remember descending is like down. D got down, right? Down. Descending mean menurun. Kalau ascending mean meningkat. Okay. So the answer is Q, R, and W. Okay, lastly, you need to write the chemical equation when Q react with oxygen. Okay, so Q react with oxygen. Can I write like this? Q plus oxygen. And then I know it form oxide, right? So I just put Q, and I know that Q is actually Q positive. So I put Q2O. Okay? And then, this equation need to balance. I put 2 here. 2 here, 4 here, sorry. Is it correct? Okay, yeah, this is the correct answer. Okay, so again, I want to mention to you and take notes. Please take note here. Many students wrong because you forgot the oxygen is diatomic. Okay, remember the oxygen is diatomic. Okay, so if you balance the equation, how I can get the 2 marks? How I can get these 2 marks? First mark is I write Q2O, the Q and the O2, correct? I get the first mark. Second mark is I put the 4 and the 2 here. So I get 2 marks here. Okay? So here, teacher share with you how to write a balanced equation and how to get the 2 marks. Okay, little bit. Write the electron arrangement for the T. T, how I can get the electron arrangement for the T is actually very simple. You just see that the T is placed in the group 2. Group 2 and is at 1, 2, 3, period 3. So from there, you can know the electron arrangement already. So it should be 2, you have 2 valence electron and use 3 shell to occupy the electron. So you get this. Okay, here I have one more questions about the calculation. You're given a balloon. Okay, this balloon with the helium gas 0.01 mole. So then you need to calculate the volume of helium. Okay, so for this question, you no need to use the emitters. You just use the mole. Right? Mole time with the molar volume, you should get the answer. Okay, and again, don't forget to write the unit. Okay, don't forget to write the unit. Okay, so we are about the end already. So dear girls and boys, you please scan this, yeah, to answer the Q&A. And maybe our moderator already share. Yeah? Moderator, please share this link to the chat so that they can do the survey. Okay, now teacher open to the floor to ask questions. Okay. Any questions before we end our session? Okay, I share again about the just now. Maybe some of you didn't get. Okay, this is the link to do the survey and to know that what you want so that we can prepare for the coming lesson. Okay, if you can scan the QR code as well here. Okay, welcome back. Okay, yeah. Okay, okay, very good. So if there's no maybe moderator can post any special question from student they would like to ask. Okay, yeah. There's a question, question says that okay, can highlight this. How to fully understand? Okay, what is amphoteric? Okay, I answer first. Amphoteric, as I say, amphoteric. One of the example is aluminum oxide. It has two properties. It can show the oxide. The oxide can show the basic properties and also the acidic properties. For example, let's say I have the hydrochloric acid, or maybe I have a test tube with the sulfuric acid. When teacher put the aluminum oxide in the test tube containing the sulfuric acid, okay, and then you can see the reaction. After that, teacher tests the product, might be with the pH paper or maybe with the reagent. I noticed that the product is neutral. So when acid reacts with something, form neutral product, that is neutralization. So that product, that aluminum oxide added, it should be base property. At the same time, if let's say I take the sodium aluminum oxide, put in a test tube containing sodium hydroxide. As we know, sodium hydroxide is alkali, like it's base. So when we put in, I do the test again. It shows me that the product is neutral. So when the product is neutral, something react with sodium hydroxide must be an acid. So this shows that aluminum oxide is amphoteric. Okay, and then there's a question asked, teacher, how to fully understand this chapter? So to fully understand this chapter is not only one lesson, 1 hour with teacher Puan Lisoim, you can understand the whole chapter totally. That is definitely the wrong concept. So to fully understand is you need to do revision. You need to do more revision, read more. Maybe you can see the video for some chemical reaction that maybe your teacher cannot conduct it in the school. It's quite dangerous. You can check in the YouTube or maybe in the software, right? So we always say what? Practice make perfect. Yeah. So you maybe you do some notes, like for example, like the beginning teacher share with you that 3 important things that maybe is always make the student confused. The trend of the trend of atomic radius, the trend of melting point, boiling point, down the group, or maybe across the period, and then the reactivity. These 3 questions is always make you confused. That's why teacher explained at the beginning. So at the beginning, teacher explained already. Down the group, the reactivity of group 1. Why? Down the group 1, the reactivity is in increasing order. It's like I have 2 people. For example, your let's say a boy. Okay, I say you. Okay, Katik. Let's say Katik with your little boy, little brother. Okay, little brother want to gain a ball or ping pong ball. So which one do you think will get first? Okay, so you can use that scenario to compare the reactivity of group 1 and also the group 17 from there. Okay, what else? Okay, van der Waals. Van der Waals force is actually the force attraction between the molecule. Mainly is for the covalent compound and also for the noble gases. So for ionic compound, we don't say van der Waals. Okay, if you say force attraction is not complete, as you know, force attraction, we got 2 types. One is force attraction from nucleus towards the electron. The other one is force attraction between the particles. So van der Waals is one type of force attraction between particles. Okay, clear? Huh? Okay, after that, how I can use this, or when I want to use van der Waals? I repeat again, we got 2 types of force, right? One is van der Waals, the other one is the force attraction. Okay, sorry, I don't say van der Waals. I say force attraction between particles and force attraction from nucleus. So see, you got 2 types. So when I'm going to use them at the right place, okay, it's like this. When you want to talk about melting point, boiling point, you mention force attraction between particles. Don't care the particle is atom ke, ion ke, a molecule ke, you use force attraction of particles. When you want to talk about the reactivity, of course you need to talk about the electron, right? Therefore, you say force attraction from nucleus towards the electron. Okay, why group 1 melting point decrease down the group? Okay, might be I show, okay. Give me a few seconds. I show you my slide. Okay, why group 1 melting point decrease down the group and then the group 18 is increased? Okay, I share the screen. Okay, remember this page? Okay, because for the group 1, they have metallic bonding. Okay, they have this metallic bonding. So when the size become bigger, the metallic bonding become decreased or become weaker. But for the group 18, yeah, for the group 18, the group 18 here, or the group 17, 18 or 17, they are different. When the molecule or the atom grow bigger, this van der Waals, this van der Waals force become stronger. Yeah, become stronger. Okay, become stronger. When the force stronger, so they need more heat energy. Okay. So what else? What other questions? Van der Waals. Okay, if I repeat again, if I'm not good, do you need to memorize the periodic table? If you can memorize, you are very good, awesome. Okay. But now in SPM, you don't need to memorize. In paper 2, the periodic table is provided. Paper 1 and 3 is not provided. Okay, but you can find your way to memorize lah. Do you believe that teacher can memorize the first 30 elements? Okay, maybe I still can remember. Let me think about. Okay, I will say hydrogen, he lived beside bank Kelvin. North of fluorine, never name magnesium. Always sings PSCl. Argon King can manage iron company near Cuba Zoo. Finish 30 elements. You can try it. Okay. Yeah. So as I say, it's actually when you study chemistry, it's not study for exam, for SPM. You study for long term. You study, like for example, the uses of the element. Yeah. Okay. So before I end, I show you one why we need to study chemistry. You see, I'm sure everyone has phone. Doesn't matter a smartphone or not smartphone. You see, these are the things that actually exist on your phone. Okay, everyone is having the phone, right? Maybe you see this live by using phone or maybe laptop. See, these are the elements that used to make your handphone, your laptops. That's why you need to study chemistry. So chemistry is our life and our future. Okay, this one is actually you can get from the internet. Okay, teacher also search from internet. Thank you for this GSI to share us this diagram. Okay, so if there's no other questions, thank you so much. I need all of you fill in the form so that I will know which topic that you need more for this e-class sharing. Okay, if no request, then I will stop lah. Yeah. Okay. Yeah. So thank you. So I will serah balik kepada kita punya moderator.
Okay, nampaknya kita telah selesai sesi bersama Cikgu Lee.
Bye.
Diharapkan amat bermanfaat buat kita dan anda terutamanya. Okay, jangan lupa isi kehadiran anda di link yang telah disediakan. Sekali lagi kita mengucapkan terima kasih kepada Cikgu Lee, Edidik, Jabatan Pelajaran WPKL, Majlis Guru Cemerlang WPKL yang mengusahakan kelas online pada petang ini. Jangan lupa jaga kesihatan diri dan stay at home. Sekian, terima kasih. Kita jumpa lagi pada sesi yang seterusnya. Bye.
Okay, I hope all of you will have enough time to do your revision. Okay. Yeah, bye-bye. Thank you.